All right, guys, welcome back. This is going to be our 7.2 video instruction. And we're going to kind of pick up where we left off in 7.1. What'd you do in 7.1? Well, you graphed equations to find the solution to the system. In other words, we have two equations, and you would graph both of them, look to see where they intersected to find the solution. And we found that there were some special cases in there where maybe there was more than one solution, but largely there was one solution to our system of equations, and we found that via graphing. In 7.2, we're going to find the solution to a system of equations, but we're going to do it using a different method, that method being substitution. Okay, you might have learned it before, you might not have, but that's what we're going to cover here. Now, I will warn you, this video might be somewhat long. It's probably going to be about 30 minutes, but it's going to be all example based. So if you need to take a break after 10 minutes, go do something, come back and then keep watching, be my guest. Whatever you need to do just to watch the video, okay? Please take good notes as we go on, because this is probably our most common method in solving systems of equations. Yeah, we're going to do graphing. Yeah, we're going to do elimination, but largely we're going to be using substitution. So how does this whole concept work? Well, the whole idea is that if one thing equals another, we can put that thing anywhere we want. It's like the concept of money in fast food, right? When you go to a fast food restaurant, they ask you for money. In return, they give you an equivalent amount of food. Because the money is exactly equal to the amount of food you get, the transition works. Okay? That idea is similar here. So let's talk through an example. I want to figure out my variables, x and y. We're trying to find what x and y are. But I notice here I have two equations with two variables. Typically in the past, we've been solving stuff like 7x minus 2 equals 12. We only had one variable, and it was very easy to add the 2 to the other side, then divide by the 7, and we got our answer. But what do we do with equations that have two variables? Well, apply this concept called substitution. I have 7x minus y equals 15. But I am unable to move the variables around to figure out what they equal. I'm always going to have two different variables. My goal here is to get the equation in one variable, right? I want to only work with x's or only work with y's, figure out what that variable is, then I can find the other. So how am I going to do that? Well, I can't do much here, but I notice that in my other equation, y equals 2x. Well, since they are exactly the same, just like the transaction between fast food and money when you go through the drive-through, where you exchange one for the other, we are going to exchange our y in this equation for a 2x. I'm able to do this because the equation tells me that y equals 2x. Okay? It's called substitution. I'm plugging something in for something else that it's equal to. So 7x minus 2x, when I do that, I get 5x equals 15, because now that my equation's in one variable, I can go ahead and solve it. Divide by 5, and I get x equals 3. But I'm not going to stop there, because I want to figure out what both my variables are, right? When we were working in 7.1, we didn't just stop when we found out. It wouldn't make much sense if we only talked about our lines intersecting at the x coordinate. No, we went the point, the x and the y, as to where the equations intersect or what the solution is. So to find your x, plug it back into either equation. Again, I'm saying either equation because either will work. Okay? When you do this, I'm going to plug it back into the first one. Personally, I would recommend always picking the easier one. When I plug in 2, or when I plug in 3 for x, again, It's equivalent, x equals 3, so I can plug in 3 for any x I see, because they're the same. I get y equals 6. Thus, my solution is the ordered pair 3, 6. Okay? If any of that didn't make sense, pause the video, go back and rewatch the example. If it did make sense, but you're like, man, I don't quite get it yet, we're going to do a lot more examples. So the word, again, that we're going to use is this process is called substituting. The whole idea is we're going to substitute one equation in for the other, solve that equation, then go back and solve our original. Okay, so let's try this together. I look at my equations here. Y equals negative 4x plus 8 and y equals x plus 7. You have a couple options here. What I'm going to do is I'm going to start with my equation y equals negative 4x plus 8. I try and make the process as easy as possible. If it looks like one equation is easier to plug in the other, do that. It would be very difficult in our first problem to get y by itself in the second equation, then plug it into the first equation. Whereas the first equation plugged in very nicely to the second. Make the process easy on yourself. So y equals negative 4x plus 8. Well, I need to get this equation in terms of one variable. I notice that y equals x plus 7. So what I'm going to do is I'm going to plug x plus 7 in for y because the two things are equal. Again, if you're confused about that, pause the video, go back to the first problem and watch my explanation, or email me and I'll happily help you. Okay, now that my equation is in one variable, I'm going to try and get that variable by itself. I'm going to get all the x's on one side, all the constants on the other. So I will subtract x from both sides. And I get 7 equals negative 5x plus 8. Subtract 8 from both sides, and I get negative 1 equals negative 5x. Divide both sides by negative 5, and I get x equals 1/5. Okay? X equals 1/5. What am I going to do from there? Well, I need to figure out my y value. Again, I can plug it back into either equation. I'm going to pick the easier one. The second one looks a little easier to me. So I'm going to do y equals 1/5 plus 7. Again, all I did was plug in the 1/5 for the x. And I get y equals 7, or if you want it in terms of a fraction, it would be 1/5 plus, turning this into a fraction, 35 over 5. So it would be y equals 36 over 5, or as a decimal, that is 7.2. So if I wrote it as an ordered pair, it would be 0.2 and 7.2. Or you could write them as fractions. Again, the 0.2 comes from 1 divided by 5. Okay, again, you're going to get this process as you practice it more and more. But the whole idea is get an equation to have a variable by itself. Then we substitute the one equation in for the other, solve for a variable, then solve for the other variable we haven't solved for yet. Seems confusing in words, but the practice is pretty simple. Again, we'll keep practicing it over and over and over again. Okay, let's keep going. If at this point you're pretty confident, I'd encourage you to pause the video and try this example on your own. If you're not, though, stick with me. So pause the video now if you want to try it by yourself. Okay. When I look at this example, it's a little more complicated. You see, what we've had in the past is we've already had a variable alone. This variable was by itself, so it made x plus 7 easy to plug in. Up here, again, we had a y by itself, so it made the 2x easy to plug in right here. But here we don't have a variable all by itself yet. So we just have to do some manipulation to get the variable by itself. Well, when I look at which equation I want to get a variable by itself, I noticed that there are coefficients attached to 3 of these. In other words, 3 is multiplied by the y, 2 is multiplied by the x, -6 is multiplied by the x. That's going to be kind of nasty to work with. But this y doesn't have a coefficient. So I'm going to try and get that variable by itself. That way I don't have to do any division or work with fractions. So in order to start the substitution process, I need a variable to be by itself. I've chosen this y because it's going to be the easiest to work with. So to get that variable by itself, I'm going to add 6x to both sides. When I do this, I get y equals -7 plus 6x. Now, these are the two equations I'm going to work with. I have 3y plus 2x equals 4 over here, but I want this equation to be in terms of one variable. Well, based on the math I just did, I know y equals -7 plus 6x. So what I'm going to do is I'm going to plug -7 plus 6x in for y. Again, the whole concept of substitution, if one thing equals something, then we can plug that thing in for an equivalent form. Okay? So I'm going to go ahead and distribute, because I want to get x by itself, and I get -21 plus 18x plus 2x equals 4. Combine my like terms here, and I get -21 plus 20x equals 4. From here, I'm going to add 21 to both sides, and I get 20x equals 25. I'm going to divide both sides by 20. And when I do this, I get x equals 1.25. Okay? Again, what I hope you see is the substitution is new. But what's not new is the whole process once I get the substitution done. Okay, once I get this -7 plus 6x plugged in, nothing in blue is new. Okay, it's all chapter 2 stuff. So if you're struggling with the chapters 2 stuff, you need to come talk to me. That way we can catch up. I know x equals 1.25, so I'm going to plug it in to one of my equations. Now, actually, there are 3 spots. We have the 2 we've been talking about. I could plug it in here, or I could plug it in here. But we said what's underlined here in blue is an equivalent form of the equation above, -6x plus y equals -7. By moving the 6x to the other side, I get y equals -7 plus 6x. Those equations are the same, so I actually have 3 spots I could plug x into. And I'm actually going to plug it into this third one. Again, why? It's the easiest to work with, it looks like to me. If you want to plug that 1.25 into one of the others, be my guest. But to me, the third option's the easiest. So I plug 1.25 in, and when I do that, I end up with y equals 0.5. Y equals 0.5. Again, you can do -7 plus 6 times 1.25 in the calculator, and you will get y equals 0.5. So what's my ordered pair? My solution, 1.25 times 0.5. Or 1.25 is the x, 0.5 is the y. Now, what it goes without saying, or what I haven't said yet, again, what is the context of these numbers? What do I mean when I say their solution? I mean, these are the two numbers that for x and y, I can plug into the original equations, and they will make those equations true. No other numbers will do that. Okay, let's move on and do another example. Again, if you're getting good at this, try it on your own before I do it, and check your work with mine. We've got another situation where we need to get a variable by itself before we can do our substitution. To me, the easiest one to work with is going to be this y. So I'll go ahead and try and get that guy by itself. Again, to me, it's the easiest because it doesn't have a coefficient. Okay, well, it does, but it has a -1, which is easier than a 2, an 8, or a 6. To get this y by itself, I'm going to subtract 2x from both sides. In doing that, I get -y equals 3 minus 2x. Then I'll divide all sides by -1. And I get y equals -3 plus 2x. Again, just getting that y by itself. Now I am able to substitute -3 plus 2x in for y in my other equation. So I get 6 times -3 plus 2x plus 8x equals 28. Again, just plugging in -3 plus 2x for y because the two are equal. Then I'll go ahead and distribute. I get -18 plus 12x plus 8x equals 28. And it's very similar to the last problem from this point forward. Combine my like terms. I get -18 plus 20x equals 28. I will then add 18 to both sides. And when I do this, I should get 20x equals 46. Divide both sides by 20. And I get x equals 2.3. X equals 2.3. Again, here I have several different spots where I can plug my x value into. I can plug it in here. I can plug it in here. I can plug it in here. Okay? To me, the easiest is this one. So when I do that, I get y equals -3 plus 2 times 2.3. And I end up with a grand total of y equals 1.6. That means 2.3 and 1.6 are the two numbers I can plug in for x and y respectively to get the equations, or they act as solutions to my equation. If I plug them in, they make the equations true. To write it as an ordered pair, 2.3 and 1.6. All right. Let's try it in a word problem. You've gotten pretty good at substitution. Now let's apply it to a real-world scenario. Mr. Carter is planning a math competition. Sorry, dropped my marker. Mr. Carter is planning a math competition because everyone loves math with all their heart. 193 students sign up to go. To transport the students, the school will be provided buses and minivans. There are 8 potential drivers. Each can drive either a bus or a minivan. School buses seat 51, and the minivans sit 8 people. How many buses and minivans are needed? Well, as you well know at this point in your algebraic careers, word problems are just normal problems, but we have the added step of setting up the equations. So let's set them up. You know I always love looking for a total, so let's reread it. Everyone loves math. 193 students sign up to go. Okay, so we have 193 students going. The school is providing buses and minivans. Okay? Well, we don't know how many. In fact, that's the very question we're trying to figure out. Therefore, I'm going to label B for buses and V for minivans. B for buses and V for minivans. There are 8 potential drivers. The school buses can seat 51 people, and the minivans can seat 8 people. So we've got 51 in the buses and 8 in the vans. All right, a lot of info. Let's set these up. Well, first things first, we got to identify the totals. The first total I see is 193. There are 193 students that are signed up to go to this thing. How are we going to transport these 193 students? How are they going to be broken up? Well, they're either going to be in buses or minivans. Okay? They're in buses or minivans. Now, specifically, how many can each seat? Well, there'd be 51 people in a school bus and 8 people in a minivan. Therefore, if we took 2 buses, we could seat 102 people. 2 minivans, 16 people. So how does that set up in an equation? Well, this equation in blue is going to be all about people. So I can have 51 people per bus, again, I don't know how many, plus 8 people per minivan. This total, this combination of people on buses and people on minivans has to total 193. We got to make sure all the students make it there. Okay? So we've done the 193. We took care of the 51 per bus and the van. But now we need to look at this 8 drivers. What does that mean? Well, we have this qualification that there are 8 potential drivers. Again, how are these 8 drivers going to be broken up? Well, some are driving buses, some are driving minivans. They can't drive both, so we have to break them up. These are our 2 equations we're going to solve. For now, we can go ahead and set up our substitution and solve the problem. When I look at this, just like I looked at the one above, to me, either of these variables are the easiest to get by themselves. So I'm going to get V by itself. I'll do that by subtracting B from both sides. When I do that, I get 8 minus B equals V. From there, as we've been doing, I can plug the 8 minus B in for V in my other equation. I get 193 equals 51B plus 8 times 8 minus B. There, go ahead and solve for B. Distribute the 8. I get 193 equals 51B plus 64 minus 8B. From there, I go ahead and I combine my like terms. And I get 193 equals 51 minus 8 is 43B plus 64. Subtract 64 from both sides. And when I do 193 minus 64, I get 129 equals 43B. Divide both sides by 43. And I get B equals 3, which means I need to take 3 school buses. Well, how many vans do I need to take? Plug it back into your other equation. I can plug it in here. I can plug it in here. I could plug it in back here. Doesn't really matter. And I figure out that I need 5 vans. 5 vans and 3 school buses to transport all the students. If you're sitting there going, Mr. Carter, I get the process, but it's still tough for me to set up that equation. I couldn't have set it up without you. We'll practice it, and you'll get better, and you'll be able to do it on your own. Okay, let's do our final problem. A rectangle is 4 times longer than it is wide. The perimeter of the rectangle is 30. Find the dimensions of the rectangle. You know I'm a picture guy, so I'm going to draw a picture of what is happening. I've got a rectangle. The rectangle is 4 times longer than it is wide. Well, to me that says that the length, just in drawing my picture, the length is going to be bigger than the width. And the perimeter of the rectangle is 30. So all of this rectangle, all the sides are going to add up to be 30. Okay? So how could we set this up and solve? Well, first things first, before you worry about solving, set up the equations. How do I set these up? Well, first, let's deal with 4 times longer than it is wide. How can we write that in equation format? Well, if it's 4 times longer than it is wide, the length has to be bigger than the width. For them to be equal, if the length is 4 times longer than it is wide, you need to do 4 times the width to equal the length. If the length is 16 and the width is 4, I would have to multiply the width by 4 to get the length. Might seem confusing. You might go, hold on, why is the 4 not with the L? Because the L is bigger. Imagine it. If the L is really big, I've got to multiply the width by 4 to get it equal to the length. So 4 times longer than it is wide, we're going to write that in equation form as 4W equals L. Now let's look at the perimeter. The perimeter totals to be 30. What's the formula for perimeter of a rectangle? Well, look at the picture. Perimeter is adding up all the sides. So what do I have here? L plus W plus L plus W. I can simplify that by combining my like terms. And I end up getting 30 equals 2L plus 2W. From here, I've got 2 equations that I can go ahead and solve. The L is already by itself in the blue equation. So let's go ahead and plug that in for L. When I do that, I get 30 equals 2, plug in 4W for L, plus 2W. Now I just solve for W. And I find out that W equals 3. Well, if W equals 3, what's the length? Plug it back into your original. W is 3, then the length will be 12. Guys, I know it's a longer video. I thank you for bearing with me. I wanted to give you a ton of examples so you get really good at this. As always, email me questions and let me know how I can help you.